Children, in similarity, we need to prove triangles similar. For example, in this diagram, the two triangles come out to be similar. That's A, B, C, D, E. The lines being parallel, children, lines being parallel. Common angle. This angle comes out to be equal to this angle. So triangle ABC is similar to triangle ADE. Students, see, it's one-to-one correspondence. One-to-one correspondence. Angle A is equal to angle A, common angle. Angle B equal to angle D, corresponding, and C is equal to E, again corresponding angle. So children, write that in proper order. And this is by AA postulate. Then children, we get the ratio of sides as first two upon these two. That's AB upon AD is equal to BC upon DE is equal to AC upon AE. Corresponding parts of similar triangles are proportionate. Corresponding parts of similar triangles are proportionate. Children, this is by AA test. We also have SAS. And we can have all three proportionate sides. That's SSS test. Just remember this, children. Also, children, we can have the ratio of this, since this is a different conclusion all in all, but the same diagram can be used. If question says, children, in the adjoining figure, FB equal to FD, it's already been given to us. FB equals to FD. AE is perpendicular to FD. AE is perpendicular to FD. And FC is perpendicular to AD. FC perpendicular to AD. Prove that FB upon AD is equal to BC upon ED. That's FB upon AD is equal to BC upon ED. So children, here we see the triangles that are formed, which are sides of the relevant things we need to prove. Children, it comes out to be this triangle FBC and triangle AED. Let's draw them separately, children. Now children, if you do realize this triangle FBD is an isosceles triangle since base angles, since opposite sides are equal, so base angles, children, come out to be equal. That base angles are equal, because of which, children, angle B will come out to be equal to angle D, and two triangles become similar by AA postulate. Write it down as a solution, children. This is to prove that. Solution would be, first, FB is equal to FD. Given. Next, children, base angles are equal. That's angle B is equal to angle D. Base angles. Since base angles are equal of an isosceles triangle, therefore, children, we get in triangle FBC and triangle AED, that's angle E equals to angle C equal to 90 degrees, that's given, and angle B equals to angle D. First part is given, children. Second part is statements above. Therefore, triangle FBC is similar to triangle. F becomes equal to A, children. B becomes equal to D, and C becomes equal to E by angle postulate. Once you get that, children, then it should be easy to come to the conclusion that FB upon AD is equal to BC upon DE is equal to FC upon AE. Children, we need FB upon AD and BC upon DE. So this cancels out, and that gives you the answer. Hence, proved. Let's see another example, children, of this kind. Children, if triangles are similar, for example, triangle ABCDE, and side AB is 2 and BD is 1.5. Children, triangle A, and this is parallel to this, so we can prove the triangle. So that's triangle ABC similar to triangle ADE by A postulate. Then children, we get the ratio of corresponding sides as AB upon AD is equal to AC upon AE is equal to BC upon DE. That's ratio of corresponding sides, children, and that would also come out to be 2 upon 3.5 to be precise. 4 upon 7 would be a better ratio without a decimal to write it down. Now children, area of the first triangle upon area of second triangle is proportional to the squares of the corresponding sides. Areas of similar triangles are proportional to the squares of the corresponding sides. So it will come out to be 16 upon 49, children. Please remember that. But if the triangles aren't similar, for example, this case, triangle isn't similar, but they meet at a common vertex and have the base to the same straight line. Then the areas are proportional to the length of their bases, children. The triangles here are not similar. These triangles are similar. For similar triangles, for non-similar triangles. Let's see some sums to apply this, children. Let's see an example, children, to elaborate that. The question says in the given figure, BC parallel to DE. If area of triangle ABC is equal to 25 centimeters squared and area of trapezium BCED equals to 24 centimeters squared, DE equal to 14 centimeters, calculate length of BC. So children, a sum like this, we would first go ahead proving them similar. That's this is equal to this corresponding angle. This angle is equal to this angle again by corresponding angles. That's in triangle ABC and triangle ADE. Angle B equals to angle D, comma, angle C equal to angle E, corresponding angles. Therefore, children, triangle ABC similar to triangle ADE, and this is again by AA postulate. Once we prove the triangle similar, children, we can get the ratio of corresponding sides. That's AB upon AD is equal to BC upon DE is equal to AC upon AE. Corresponding parts of similar triangles are proportionate. Once we get that, children, we can also write down areas of similar triangles are proportional to the squares of the corresponding sides. That's area of triangle ABC upon area of triangle ADE is given to us as area of triangle ABC, which you already know, upon area of triangle ABC plus area of trapezium BCED. Because children, this is 25 and this is 24, so the full thing comes out to be 25 upon 25 plus 24, that's 49. Well children, we also know that this is equal to ratio of proportionate sides, and we've been given the value of DE, so we'll use this ratio BC, which we don't know, upon DE the whole squared. That becomes, children, when you square root both sides, 5 upon 7 is equal to x upon 14. On cross multiplication, children, we get the value of BC, which is also the value of x as 10 centimeters, children. So we see, children, how we apply the theorem backwards here when areas of similar triangles are proportional squares of corresponding sides, and use that. The reason for this is areas of similar triangles are proportionate to squares of corresponding sides. And then we get the ratio, the length of BC, children. Let's see another question, children. Question says, children, in the adjoining figure, triangle APQ is similar to triangle ABC. This is 12 centimeters, this is 15 centimeters, this is 3 centimeters, this is 4 centimeters. Also, what's given to us, children, PQ and BC are not parallel. PC is 4 centimeters, as it's written down over here. AQ is 3 centimeters. QB is 12 centimeters. BC is 15 centimeters. Assuming that AP equal to PQ. AP equal to PQ. Find the length of AP. Now, children, we'll take this length as x. We'll take this length as x. We already know, children, triangles are similar, but we should understand that part clearly, children. How are the triangles similar? That's what's going to help us in solving the sum. Children, the full side AB is equal to full side BC. So this angle is equal to this angle since it's base angles. And here, this is QAP. This is equal to this. Now, children, if this is equal to this, and we already know this is equal to this is x, which is equal to this angle x. And accordingly, children, this angle comes out to be equal to this. It really doesn't matter because, children, both the triangles are isosceles. Now, whether you say this is equal to this or this is equal to this won't make a difference. This is the third angle of the triangle. This is the third angle of the triangle, children. Now, what do you need to find out? We need to find the length. Find length of AP, ratio of areas of triangle APQ and APC. So now, children, first of all, we specify in the right way triangle ABC similar to triangle A, we said is equal to angle A, B we discuss is equal to angle P, and C we discuss is equal to angle Q, which has already been given to us. If we don't need to do any test or anything, it's already been given. We just need to get the right order. Once we get that, children, we need to get the ratio of sides. That's AB upon AP is equal to BC upon PQ is equal to AC upon AQ. AB is 15, AP is some length y, AC, come to AC, children, AC is y plus 4, AQ is 3. Now, children, we'll cross multiply. This is corresponding parts of similar triangles are proportionate. Now we cross multiply, so we get 45 is equal to y squared plus 4y. 0 is equal to y squared plus 4y minus 45. Children, 45 factors will be 4 and 9. So that's y plus 9. Y minus 4 is equal to 0. That gives us y plus 9 equals to 0 or y minus 4 equals to 0. Y is equal to 4 or y is equal to negative 9, which is not possible. And children, the value of y is AP. So AP equals to 4 centimeters, children. So now we get this length as 4 centimeters. Now children, the second part, for the B part, this was part A. Now for part B, area of triangle ABC upon area of triangle APQ would be side 1 upon side 2 the whole square. As proportionate side, which you can take it as any, that's AB upon AP will also work. Well children, we already know the value of AB. AB is 15 and we got the value of AP just now as 4 the whole squared. Come out to be 225 is to 16. 16 parts to 25. 225 is to 16 children. That's the ratio of the areas. And the reason would be areas of similar triangles are proportionate to squares of corresponding sides. So children, this is how we use area theorems and work backwards. Let's see another example to elaborate on this. Question says, a map is drawn to scale of 1 is 20,000. Distance between two towns, the map is 9 centimeters. Part A, distance between two towns on map is 9 centimeters. Calculate actual distance in kilometers. Calculate area which represents 9 centimeter, 8 square centimeter on the map. So children, first we'll do the distance. For distance, it is map and the actual plot of land. It's 120,000. So if this is 9 centimeter, how much? We cross multiply, so it becomes 9 into 20,000. We convert into kilometers, children, we divide by 100,000. That's 1.8 kilometers in actual case. Next we do area. Area would come out to be map and plot. Map 1 square, 20,000 squared. Map is 8 centimeters squared. How much? It becomes 8 times 20,000 times 20,000, and then we divide by 100,000 children. Convert from kilometers squared, centimeters squared to kilometers squared. So that's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now shall we just multiply and divide by 100? That's 8 times 2 times 2. That's 8 times 4. That's 32. And 0.32 kilometers squared would be the area. That's it children. That's for the crash course. Thank you.